Hello students, today I'll explain to you why the objects are sinking. What is your answer? You will say that weight is more, so the objects are sinking. But what about the ships and boats we see in our day to day life? They all are floating, even they have thousands of cages, they can able to float in the water. Only weight does not make the objects to sink. If only weight makes the objects to sink, the whole ship can able to sink in the water. But it is not happening. So there is another thing which we are going to discuss in this video. That is what? Buoyancy. And buoyancy. Today I'll explain you an activity. Let me do that activity with the arrangement setup that I have taken here. When I am going to drop this rock into the water, the two forces are acting on this rock. One is weight in the downward direction, another one is buoyant force in the upward direction. Here, why the rock is sink into the water means the downward force weight is more than that of the upward force buoyant force. So, downward weight is more than buoyant force which is in the upward, so that it is sinking into the water. Let me discuss how to find out the buoyant force now. To find the buoyant force presented in the water, we need to have some arrangement setup. For that, I have taken a overflowing jar. It is what we call it as overflowing jar, and a stone, and we need to consider a small weighing machine to measure the weight of the object. Now, first I am going to set the overflowing vessel with water. I need some more water to set this. As soon as it reaches the maximum height, we should stop. Even we pour some more water, the overflow will come outside and sets the overflowing vessel to the top level. The setting of the overflowing vessel we note now. The overflowing vessel is set now. Now let me remove all the water which is presented, excess water which came from the overflowing vessel. I am going to take it out. Now to find the buoyant force on the rock, now I need to find out the weight of this rock. Let me switch on the weighing machine, and I am going to place the rock on the weighing machine. You can see the value is shown on the weighing machine as 60 grams. So the 60 gram weight I am considering there. Now we see how much buoyant force will be. Now to measure the buoyant force which I am going to place, when I am going to place this rock into the water, there is a buoyant force, right? To measure the buoyant force based on the Archimedes principle states that the water displaced by this rock, the weight of the water displaced by this rock is equals to the buoyant force. So for that I need to measure the water weight only. For that I am going to consider this extra mass, the vessel extra mass, I am going to take it as 0. Now the vessel is showing that the 0 weight when I am going to place inside. So with this we can able to find only water displaced weight of the water displaced by it. Now I am going to consider this stone. I am going to put it into the overflowing vessel. When I am going to place the rock into the overflowing vessel, you can observe some water which is coming out from the overflowing tap and fall inside the vessel. As I am going to put this stone into the vessel, you can able to see some water which came out. Finally it stops overflow. Until that we should wait. As the stone is inside the water, the overflow came outside, means the volume of the stone displaced some amount of water from the vessel. Now I am going to measure the fluid displaced by the stone, that is equals to the buoyant force. Fluid displaced by the stone. You can see the weight of the fluid displaced by the stone is 22 grams only, but the weight of the stone is 60 grams, we already noticed, so that the downward force is more than the upward force, which is buoyant force. So downward force is 60 grams, upward force is 22 grams. So what do you understand from this? The less buoyant force on the stone, so stone sink into the water. Thanks for watching this video. In the next video, I will explain you why objects float. Signing off, Ramesh Kumar, Polepalli.